All right, so we're going to take a look at another AP statistics question. This time we're going to take a look at the 2012 exam. It's going to be question number 2. So I'm just going to read off the question here. A charity fundraiser has a spin the pointer game that uses a spinner like the one illustrated in the figure. I've written out the figure here. A donation of $2 is required to play the game. So to spin the wheel once, you need to pay $2. For each $2 donation, a player spins the pointer and receives the amount of money indicated in the sector where the pointer lands on the wheel. The spinner has an equal probability of landing in each of the 10 zones. So you're paying $2 to play this game. Unless you hit the 10, you're actually paying at least $1, most likely $2, to play the game. But anyways, the question says, let X represent the net contribution to the charity when one person plays, and asks us to complete the table. So X is the net contribution, and we're going to get $2 if the pointer lands on 0. We're going to get $1 to the charity if the pointer lands on 1, 2 minus 1, and we're going to lose $8 from the charity if the pointer lands on 10, 2 minus 10, negative $8. So since there's 6 of 10 spots with a 0 rather, and they all have equal likelihood, the probability of 2 is going to be 0.6. Since there's 3 spots with a 1, 2 minus 1, expected contribution 1, and then probability of that is going to be 0.3. And then we're left with 0.1. 1 out of 10 spots is going to get us negative 8, and it also completes the probability adding up to 1. So fairly simply, we've completed the table of probabilities for X, the net contribution after one spin. Now we need to find the expected value of the net contribution, also the average of what the net contribution after one spin is going to be. All we need to do is multiply out 2 times 0.6, 1 times 0.3, negative 8 times 0.1 to find out what that expected value is going to be. So it's going to be 1.2 plus 0.3 minus 0.8, and that's going to be 0.7. This is a positive value. It's in dollars, so it's 70 cents, and we're going to say that the expected value of the net contribution is going to be 70 cents. So now the question asks us to move on, and the charity is looking for a net contribution of $500, of at least $500. So we need to find out the fewest number of spins, the fewest number of times we need people to play this game in order for that contribution to be at least $500. So we're going to let N represent the number of spins that we're looking for. We know that each spin is going to be expected to generate $0.7 or 70 cents. So we can set 0.7n greater than or equal to 500. Again, this is because the expected value of one spin is 0.7. We need n spins to get to greater than or equal to 500. And now all we need to do is simple division. So we have n greater than or equal to 714.286 spins, we can't have a decimal spin. So greater than or equal to 714 point something is actually going to be greater than or equal to 715. So we're expecting that the fewest number of spins for the expected contribution to be at least $500 is 715. That's not necessarily true. You could have a couple hundred spins landing on the 10 for no apparent reason. It's complete probability, but we're guessing that the fewest number of spins for the expected contribution. The key word is that that contribution is what is expected. So now in part D, the charity, we're getting told that the charity gets 1,000 spins of the wheel, and they're asking us for what the probability is for the net contribution to be over $500. Well, N is equal to 1,000, and the expected value is going to be N times what we calculated down here in part B. So really it's just going to be 1,000 times 0.7. So the expected value after 1,000 spins is going to be $700. Now it's just going to be simple, calculate a z-score to figure out what the probability is. This part of the problem actually also gives us the standard deviation value, which I forgot to write down here. I'm just going to put it off to the side right now. And again, this is the standard deviation of the net contribution of 1,000 spins. And then the mean is just that expected value that we calculated originally. Now we can finish out the z-score. I actually ordered this wrong originally. This is supposed to be 500 minus 700. It wouldn't affect your probability in the end as long as you correctly interpret the z-score that you're figuring out. But this is going to be a direct way to figure out what we have going on. So we have z equals negative 200 over 92.72, or negative 2.155. And we're just looking for now the probability that 1,000 spins is going to generate greater than or equal to 500 is just going to be the probability that z is greater than or equal to negative 2.155. All you're going to have to do is look up this value in your table, and we're going to get a z-score of 0.9844. So that 0.9844 z-score is tells us that we have a 98.44% chance that 1,000 spins is going to generate over $500 for the charity.